Yeah, good afternoon to all. Uh, now we will see the unit step response curves of a second order system for a different xi. In previous video also psi and eta. Mistakenly instead of xi I told eta you should consider it as xi only. Now here for xi is equal to 0 you can see the response that is purely oscillatory. As I increases you can see that the oscillation is damping, okay, damping, and psi 1 you can see for psi 1.5 also what is the change you can see here. Now when you are looking to this, it is pole locations of a second order system. Here they are keeping omega constant and psi psi varying from 0 to infinity. How the pole locations. Now when psi is 0 you can see the poles on y-axis and you can see the distance is omega n. Yeah, so this is the omega n distance. Now when if psi is between 0 and 1 you can see that the poles will be in this curve anywhere. Okay, this is for a positive and this is for a negative. Yeah, here it is psi is psi is between 0 and 1. Now when psi is 1 you are getting the poles over here, and psi greater than 1 you are getting the poles on these two locations. Okay, so if you look into this, as I increases the poles move away from the imaginary axis along a circular path of radius omega n. This is a radius path of omega n, meeting at the point sigma is equal to minus omega n, and then separating and traveling along the real axis. Okay, here when it reaches it will go psi when it is minus omega n. Here one towards 0 and other towards infinity. Now when you are coming to the time response, all of you look into the figure very clearly. So you can see there are overshoots and undershoots, and there is the time response. So here what is rise time, what is delay time, rise time, peak time, and peak overshoot, settling time, steady state error, everything we are going to study. Now, here the response is the time response of second order or and a higher order. This is the response of the second order or higher order. Now, what all are the transient response specifications as follows. Delay time TD. The delay time is the time required for the response to reach 50% of the final value the very first time. So 50% of delay time is the time required for the response to reach 50% of the final value. So here this is when you are observing it, this is final value, this is the 50%. So this is the time required to reach the 50%. Here y-axis is output and x-axis is time. So the time required to reach 50% of its final value. So that is TD. And next one is rise time TR. Rise time TR. The rise time is the time required for the response to rise from 0 to 100% of the final value for underdamped systems and from 10% to 90% of the final value for overdamped system. So here it is in an overdamped system, it is 10% to 90% of the final value in case of overdamped system, and for underdamped system it is 0% to 0 to 100%, 0 to 100% for final value for underdamped systems, and from 10% to 90% final value for the overdamped systems. So in this case, it is an underdamped system. It is an underdamped system. It is an underdamped systems, and